All right, so I was here. Yeah, measuring resistance. So previously the voltage is measured always over this device. Then this current is measured from the current. When you put the current meter on the way, that current flows in between the resistor, so it's connected series to the resistor. When you're measuring resistance, you practically need to measure voltage and current at the same time, meaning that if you have the device that you want to measure is actually as a part of a circuit, like in here, you need to disconnect the terminal, at least one of the terminals. So you need to make this one, the device what you are measuring the resistance, you need to make that one floating, so to speak. So now I can actually use the multimeter to measure the resistance. And start simulation. Okay, it looks like it's 1 kilo ohm resistor. However, let me stop the simulation and put a wire. I'll show you what happens. If I try to start the simulation, it says error because you cannot actually measure a device that way. However, this is a nice feature of the Tinkercad, but in real life you can actually try to measure a resistor that way as a part of the circuit which has power on, and you get really funny answers. So just as a warning and reminder, disconnect the device if you want to do measurements of resistance. Okay, power. What is electric power? Electric power is actually when you are
One
talking.
question. Sorry
Yes.
for interrupting you constantly, but could you further elaborate by demonstrating what do you mean by disconnecting the device? How
Okay,
would
sure.
you measure anything if there's no power running through?
Well, that multimeter has the power. Haha. So for this measuring voltage and current, actually, then you can actually measure the voltage here, since this is a separate device which runs its own battery.
Fair enough.
Yeah.
No, that makes sense.
Yeah. So practically, this multimeter has battery inside, and then you can start doing measurements. But okay, voltage and current can be measured on a complete circuit, although measuring the current means that you have to disconnect it first and then put that current flowing through the component. And measuring the resistance means that you basically need to disconnect that device you want to measure from the circuit first. Otherwise you get funny results. Or not results at all. Okay, how to measure power? Or what is power? Electric power is a product of current and voltage. So volts times amperes is watts. So which is actually the same in case of the DC as the voltage squared divided by R, or a current squared multiplied by R. Okay, and here's an example again. Measuring power. one of them. Let me make this one a little bit bigger. And I can also change the values here. Okay, 9 volts battery, and then there's a resistor which size is 2 kilo ohms, and our current meter is connected actually in the series with the resistor, meaning it's on the way of the current. So current flows through the ampere this current meter, and then we measure also the voltage across the component here. So if I start the simulation, okay, I got about 9 volts and 4.5 milliamps. The power would be a product of those. Let me change this to ohms. Oh no, now we have quite a lot of power. So voltage about 5, and we have 2.5 amps current, a little bit more than that. It's more than 10 watts of power consuming in a very small component. What do you think happens? It burns out, of course. It just became a fuse. There. So that's how you measure power. So separate measurements of U and I. Okay, when we have the alternating current, then basically we are talking about instantaneous electric power, which is still U times I, but now both voltage and current can be basically changing by the time. So basically there we are more interested in active power averaged over a certain time. So we integrate U times I over a certain time from T1 to T2. Usually, if alternating current, well, that's usually either 50 Hertz in Europe or 60 Hertz in America. You actually integrate over one full cycle. Then you get the average power over one full cycle. But we started with the DC. We'll continue with the AC not next week, but the following week, I think. Okay. LED, light emitting diode, which is a semiconductor. What is semiconductor? Well, was it next week or the following week? We will talk about semiconductors, or that might be actually later on. But basically it's a unipolar device, which means that it works only when the polarity is correct. Brightness depends on the current, not the voltage, but the current. The brightness actually is quite linearly dependent on the current. Resistance is highly nonlinear. At some point you might actually also measure it. It requires always a series current limiting resistor. You can actually damage either the LED, or even worse, you can actually damage a microcontroller if you connect an LED to the output pin without a protecting current limiting resistor. Okay, where to use it? Usually indicator. Those colored LEDs are usually indicator LEDs, and then or actually white LEDs, they are light sources. And more details will follow later, but for the afternoon exercises with this Arduino, you need to use that component. Oh, there's still that one funny extra LED here. Well, no, it's not there. That's funny. See? it shows an extra LED here, but it's not on the design. Well, Tinkercad is not perfect. Okay, simple coin battery device, and in series you have the current limiting resistor of 50 ohms, and then you also have a variable resistor. And we start simulating. Actually, you can see that the brightness of the LED actually changes. Okay, that's in this connection, when this dial is in here, you the output pin is actually giving the lowest resistor between this terminal and that terminal, and here actually it's the higher resistance in between. Okay, so that's a simple light dimmer for LED. One advice: don't ever, never use this circuit in real life. It just wastes your energy, since the dimming is based on actually adding resistance here. The right way of light dimming is pulse width modulation. There. Okay, so that's LED. Oh, I could have also shown the. Sorry about that. I have the same head day and night. I'm so fast on closing these circuits, all these windows. Okay, let's try something, and just for fun. Wait a minute, can I? I tried to reverse the polarity here. Okay, and let's start simulation. See, no light. I reversed these the terminals. So practically, if you want to use an LED, then that terminal, which is a little bit bent here, there's a curve here, that's the positive, and then the other one is negative. So from anode to cathode. The naming of these terminals is actually from the era of the tube amplifiers. So anode and cathode. All right, LED examples. Power indicator. In this left-hand side picture, I have actually used a classic 555 type circuit, which is basically one of the first mixed signal circuits. It has a couple of comparators, and then it has some flip-flops, meaning digital gates, and it can be used to make for example, a self-triggered multi-vibrator. If you are interested in electronics, there is a link. Go and check how it's connected. But anyways, this is more or less how it works. So on this design, there are few resistors and one capacitor to set up the timing of this circuit. And then we have the power indicator LED, meaning that okay, LED this power is on, and then we also have the another LED on the output of this oscillator, and when I press simulate, okay, start simulation. Okay, there I actually also have the oscilloscope showing the waveform which is coming out from the 555. So the oscilloscope, it's a voltage meter which measures this. Well, it shows that change of voltage as a function of time. So it takes samples and just plots those. And I have the power on and off. When I turn off, okay, power indicator LED goes off, and then also the signal dies. Okay, so that's how it works. So both of these LEDs here also have the current limiting resistor. Another blinking LED, simple Arduino kind of thingy.
I have a question. Is this recorded?
I hope so. Let's see. Yes, I am recording it.
Good.
Thank you for checking it out. It's sometimes I forget. Okay. Well, I'm recording with the OBS. It doesn't show up on any screen. So.
Good.
Okay. So yeah. So start simulation here. That also blinks the LED. Blink. Okay. Now we can actually compare. Well, I have just a very simple Arduino code here. Set up, and then what to do in a loop, meaning turning wire high and delay 1 second, turning it low again. Very simple code, and I got this one blinking. Compared to the old school, this is also blinking, right? But look at the amount of electronics. So yeah, but you already kind of knew that one. So it's for at least for me, it looks like we have a winner of making LED to blink. Yeah, and there's a power on LED here. Stop simulation. Hey, now it's time again for a break, about 5 minutes, and then basically it means that, okay, let me take that one, not back at 9:51, but 10:30. We will continue 10:30.